Hi, and welcome to Calculus Examples. I'm Dr. Finch. Today we're going to look to find the volume of a sphere of radius r. So I'm going to start off by drawing out our sphere. We have radius capital R in here, so that's the object that we're looking to find the radius of. Because we are going to use calculus to do that, the first thing that we're going to do is pop this onto an xy axis, especially since we are going to be using Calc 2 techniques for this. So we have an x and y axis here. Traditionally, what we're going to do is we are going to take and have this line, which and rotate it around our x-axis. In fact, what you can do is you can say, I'm going to take the whole half circle and rotate it around. That is going to give us a sphere-like object when we toss that around the x-axis. Now, when we try and find volume in calculus, we're going to chop up or slice up the object that we're working with. So notice our little slice here. We are going to figure out what the volume of that slice and what it looks like. So volume of our slice, and I'm going to denote it V sub S, S for slice, is going to be approximately, well, let's see, when we take that object and we rotate it around, we end up getting something that looks like a circle. And it's got a little bit of X height to it. So we're going to call that change of X. We're going to put that on the back side. This is change of X is going to turn into our dx when we upgrade this into an integral. And then for the volume of a circle, or I should say the area of a circle, because the volume is from that change of x, the area of a circle is pi times our radius squared. You'll notice here that our radius is going to change as we move along the x-axis. So it's going to be a y value of some sort. I'm just going to pop in right now, I'm going to pop in y squared, pi y squared, change of x, and we're going to figure out what that y is in terms of x in just a little bit. So the volume total for our sphere, now instead of doing the whole thing, I'm just going to do from 0 to r, and I'm going to multiply it. So x is equal to 0 is right there. X is equal to r, and you'll see the volume on this side of our sphere is going to be the same as the volume on the second side, on the back side. So we can just double it and go from 0 to r. And then we are going to pop in our pi y squared, and our change of x turns into a dx. All right, so now the next thing is we need this y squared in terms of x. Because we know that that volume is going to change, or that distance, that y value we have is going to change. All right, so let's look at our picture right here. We know that this is a circle. And how do we define a circle? Our circles are defined by x squared plus y squared is equal to our radius squared. Oh, how lovely. And in fact, I'm going to rewrite that down here. X squared plus y squared is equal to capital R squared. In other words, y squared is equal to r squared minus x squared. So the equation for a circle is something that is very useful in Calc 2. I highly recommend that you know that equation. It's not that hard and it's super duper useful. So instead of y squared, we're going to put capital R squared minus x squared dx. The pi can actually come on the outside of our integral because it is a constant, so we can just yank that out. R squared minus x squared dx. And now when we integrate that, we end up with 2 pi r squared. We are going to tack on an x there, minus, and instead of x squared, we are going to add 1 to our power. So that's going to be a 3, and we're going to divide by our new power. So that's 1/3. And we are evaluating this from 0 to r. So let's put in our r value first. R squared times R is R cubed minus 1/3 R cubed. When we plug in 0, everything disappears because everything has an x attached to it. So we don't have to worry about that. R cubed minus 1/3 R cubed gives us 2/3 R cubed. And now we can just rewrite it as 4/3. Because 2 times 2 is 4 times pi times R cubed. And there is the volume of our sphere. Thank you for listening.